So the picture they give us this time. Looks like this. My drawing won't be the greatest. Number one, what kind of graph is that? Histogram. Good. Histogram. When it looks like this, is it symmetric, uniform, skewed left, or skewed right? Skewed right. It's got the tail on the right, and it's skewed right. Next question. 31. Says finding and discussing mean, median, and mode. Find the mean, median, and mode of the data if possible. If any of these measures cannot be found or the measure does not represent the center of the data, explain why. Help me out here so I don't have to hold this book. We got a stem and leaf plot, right? And the key says it's just normal. So let's list the numbers out in order. What's the first number? 30?
32.
32.
33. 35. 36. 38. 39. 40. 41. 42. 47. 48. And 51.
51. 1, 2, 3. Somebody count the leaves for me while I'm counting this up here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 23, 24, 25, 26, 27, 28. There's 28 leaves in there.
Yeah.
Just to make sure we got them all. First thing, we want to find the mean, median, and mode. What's the easiest one to find probably once we have it listed out like this? I think mode's probably the easiest, right? Is there a mode? Two of them. So this is bimodal. 24 and 35, that's one of our answers. Median might be the next easiest one to find. We just counted, there's 28 numbers in this list. What I do when I'm trying to find the median, 28 numbers, you got them listed in order. What's half of 28? 14. Now 28 actually splits up exactly 14 and 14. So that means if I count 1, 2, 3, 4, 5, 6, 7, 8, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. That's the 14th number from the low end. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. That's the 14th number from the high end. There is no exact middle number, so we add those two together and divide by 2, but it's nice when they're both 32, because if you add them and divide by 2, what do you get? 32. So that's the median. Mean, what do we have to do to get the mean? Add them all up, divide by how many of them there are. Somebody add them up for me, because I'm going down on my calculator. Probably need more than one person to be adding them up, because one person adds them up and they get the wrong answer because they pushed the wrong button. We need to know. $835. Anybody else get that yet?
Well, that's divided by 28 would be 29.
You got 835 though. Add it all up.
How many numbers is there?
28.
I got 29.8.
29.8.
When you divide it by 28.
That's what you said. So 835. Everybody came up with that, right? 835 divided by 28. 29.8.
Yeah, 8.2.
And we remember we said we want to go out one place, since these were just whole numbers. Want to go out one extra place anytime we round it off. Now you just punched all those numbers into your calculator, and what I'm going to show you, since you had to punch them in here anyway, the best thing to do would have been to do this. Hit stat, so on your calculator, hit stat. The very first thing says edit. We're going to do this today anyway. So hit enter, and it pops up these lists. What we could have done is just type them all into that list. You just type them in to add them all together on the calculator anyway. If you type them into list 1, then they're in there. And we can do a whole bunch of different stuff with them. Alright, so if I took all these numbers, you just hit 6, enter, 7, enter, 12, enter, 15, enter. You're going to have to do this today. Well, I shouldn't say you have to. You're going to want to do this today. Bad thing with typing into this list, you get about halfway down. If you're like me, you get sidetracked and forget which number you were on or something. Forget, especially when you get to like the 35s and there's more than one, you might have to go back and count them. And if you got somebody talking like me all the time, it's probably confusing the heck out of you. Now, when you do get down to the bottom and you punch in that last one, if you look down here at the bottom of the screen, it'll say what line you're on, and mine says 29. Well, that's because we had how many numbers? 28. Now, on this calculator, it's actually got other numbers in there, so I need to delete them. Any other numbers that are left in that list. So I'm just going to go down through and delete all those that are in list 1 until I get to a blank one. What world set of numbers did they have? There it goes.
Mr. Eddie.
So what was our last number? 51, wasn't it? I must have hit the wrong thing. I hit 54. 51. Now that's on our list here. And anything we want to do with it, we can. If I hit stat again, it's got edit, sort, clear list, so on and so on. The sort, you could have just, without it being in order, you could have stuck it in here, and then it would have sorted it into order for you. What we're gonna do today is, and what you could have done with this stuff, is we're gonna scroll over to calculate, C-A-L-C. So we scroll over to calculate, you hit enter, and it says one variable stats. Well, what we gotta do there is tell it where to get the list from, so it's gonna be list 1. If you put it in list 2 or list 3 or list 4, then you put in that. The way you get to list 1, you hit second, and if you look at the numbers 1, 2, 3, 4, 5, 6, 7, they all have a L beside it, or up to 6, not 7. We want list 1, so my calculator looks like that. Says one variable stats L1. So I'm telling the calculator that I want it to do all the statistics for list 1, all the numbers in list 1. You hit enter, and it calculates a whole bunch of different stuff. Some of this we're going to learn today. The very first thing that it calculates is X bar, right? Which is the sample mean. And then it's got, what's that next line? Sum of all the x's. You guys told me it was 835. What's the calculator say it is? 835. Then the next thing, it's got the sum of x squareds. That's some of the stuff we're going to do today. All right? So it will do all that for you instead of you have to do it out longhand. Then the next one is S. That's another thing we're going to do today. Then the next one is sigma. Another thing we're going to cover today. You scroll on down, it says N is 28. N is how many numbers are in the set. Scroll on down, it's got the minimum. What was the lowest number in our set? 6. Then it's got Q1. Anybody know what the Q's stand for? That's something we're going to do later on in the year. We won't, it'll be a few days. Quartiles. All right? A lot of you taking tests like ACT, SAT, entrance exams, stuff like that. That's where the quartiles come from. What quartile ranking are you? So if you see like a percentile ranking, if you read your ACT and it says you were in the 50th percentile, something with quartiles, sort of tells you something about that. We'll talk about that. Then the next line says MED. What do you think that is? Median. We said the median was 32. The calculator here tells me it's 32. Then it's got quartile 3. Then it's got the max, which is the highest number, and that's all of them that it has. So it's got all that stuff on there. Got to be able to punch them into those lists. That'll make everything a little easier. It said to explain if any of these numbers don't really represent the center of the list. Of all those mean, medians, and modes, what's the only one that maybe doesn't represent the center of the list? One of the modes. Which mode? All right, that's a little low, right? So it doesn't represent it. Just happened to be one that occurred 3 times down closer to the bottom of the list. The others, even 35, not too far off from the center of the list. So any of these could be used as a good representation of the data. Other questions? We want what? What, clear the whole list? It'll clear. Got to go to edit or go to stat. Go to into. You didn't punch in what number list you want to clear. So you gotta hit clear list and hit second L1 or L2 or whichever list you're trying to clear. Other questions? Nope. Is everybody gonna be able to get a calculator or does everybody have one? If you don't have one, let me know. I'll try to help you out and try to find one. Speak now. Alright. You heard me, right? Recorded for posterity. Don't ever want anybody to say Mr. Eversole wasn't trying to be nice at one time. Measures of variation, that's what we're going to cover today. Measures of variation. What's the word variation mean? How it changes. How something moves up or down. How things vary. So that's what we're going to deal with. How things vary from one piece of data to the next one. Measures of variation. What we covered before, measures of central tendency. What tends to happen in the center of the data. Measures of variation is how the data changes as you go from the high or from the lowest to the highest. What's occurring? Does it jump from real low up to real high real quickly? Does it sort of move across pretty evenly? Just how do things vary? What we're going to do, how to find a range. You probably know range already. Notice when you were in 3rd grade or 4th grade and you found mean, median, and mode, you also found what? Range. Why that stuck with mean, median, and mode, no clue. Some math person, when they said, oh, well, we could teach a range because it's easy. That's probably why it was. But it shouldn't be, because range is variation. Range isn't what's going on in the center. Range is how it goes from one end to the other. How to find variance and standard deviation. Brendan, you see those two words? We're going to use them all year long. You're going to learn to hate them. All right? Empirical rule, Chebyshev's rule. I guess that's how you pronounce his name. I have no clue. Don't really care. Those are rules that we use dealing with this stuff. We probably won't get to that today. That'll probably be for next class. How to approximate the sample, standard deviation. We're going to deal with samples again, samples and populations. You'll have a variance for your samples, you'll have a variance for your populations. You'll have a standard deviation for a population. You'll have a variance for a sample, standard deviation for a sample. Two different things. How to use the coefficient of variation to compare variation in different data sets. Again, I don't think we'll get to that today. We'll probably get to that next time. Range. This is the easiest part. I don't want Camden, just because we do the range, he's going to go, oh, Emerson lied to us. This stuff's easy. Range is easy. The other stuff that we're going to cover today, not near as easy. All the range is maximum minus minimum. Maximum minus minimum. So you find the highest, find the lowest, subtract them, that gives you the range. Data must be quantitative. What's it mean to be quantitative again? It's got to deal with numbers. All right? So you can't say maximum minus minimum when we're talking like freshmen, sophomores, juniors, and seniors. We can't say seniors minus freshmen. Doesn't work. It's got to be quantitative. Nothing real hard about this. It's easy, but it only uses 2 entries. And usually if you have an outlier, where does it fall? One of those 2 spots. It's either the highest or the lowest. Alright? So range is easy, but it only uses 2 pieces of the data, so it doesn't really tell us a whole lot. Tell us a little bit. If you're you get out of school, you move out of your folks' house, and you have to start paying a water bill. and you pay for a year or two, and you're looking back at your water bill so that you can start to try to budget how much money you need to pay for the water, and you look at your lowest bill was $72, your highest bill was $180, you can use those two to sort of know that you need to be in there somewhere as your budget. Highest and lowest, what is the range? What's the first thing you're going to do when you're trying to find the range? Put it in order. So these are starting salaries. A corporation hired 10 graduates. For each graduate, or the salaries for each graduate are shown. Find the range of the starting salaries. We want to put them in order, which I did there. Lowest is 37,000. The highest 47,000. What's the range going to be? 10,000. So $10,000. That's the range. Lowest starting salary compared to the highest starting salary. Deviation. Difference between data entry. Our data entries are always X. So difference between data entry and the mean of the data set. That's how much it deviates. I'm going to give you a second because I really, really want to explain this. Notice this is just deviation, not standard deviation, just deviation. How much each one differs. So what you're saying on this, we got a set of data. From here to here is our set of data. The mean is probably going to fall somewhere in the middle, correct? And what we're doing is we're looking at each piece. So there's a piece of data right here. Deviation is how far from the mean that piece of data is. Then you have another piece of data here. How far does it deviate from there? Then you got another piece of data here maybe. How far is it from there? Then you got another piece. How far is it from there? You got some pieces over here. How far are they from there? So on and so on. That's what deviation is. How far does each piece of data deviate from what we consider the middle, the mean? So that's what deviation is, how far it is. Standard deviation is when you take all these deviations and you figure out the mean of all of them. And that's where stuff starts to get a little more difficult. All right? We talked a little, at one point we talked about line of best fit with the babies, with the weight and height of a baby. And we said the line of best fit might be like this. The way they get that line of best fit is from their scatter plot. Got all these points, and what they did to find that line of best fit is they put in a line and they said, all right, how far is this one from the line? How far is this one from the line? How far is this one, this one, this one, this one, this one? They averaged all those up and then they found the mean of each one of those. All right? And they said, well, I wonder if this line would be better. And that's where you get the line of best fit. Which one has the lowest deviation? I know that doesn't make a whole lot of sense right now, but hopefully it will. For a population data set, to find the deviation of X, we do X, that's your piece of data, your one separate data piece, minus, what's that symbol again? mu. Mu, which is your mean. Mean of the population. Population mean is mu. What do you think the next line is going to say if this dealt with population? Sample. Does anybody remember what was the symbol for the sample mean? We just had it on the calculator a minute ago.
This is the X line above the
X bar. X bar. So for a sample, it's X minus X bar. That will give you the deviation. Mu and X are the means. X is each piece of data. We didn't have a quiz today, but no, we will be taking a symbols quiz before too long because we're starting to get into a whole bunch of symbols. You got to know what those symbols are. All right. So if on the next, when we do take one, probably next week, if I put this on there, what are you going to put as your answer?
X bar.
No.
Sample.
Sample mean. Sample mean. If I put this on there, what are you going to put?
Population.
Population mean. Sample mean, population mean. Again, this is just deviation. We're not even talking about standard deviation yet. Standard deviation is taking all those deviations, how far each piece of data is from the mean in the set, adding them all up, and divide by how many pieces of data there were. Corporation hired 10 graduates starting in so we just went over this problem. We go to this, we find the mean, add them all up, divide by how many of them there are. Notice here, and we're going to talk about this here in a minute, they use the capital N. They use the capital N because we're dealing with a population. That's all 10 of them that they hired. All right, it's not just a sample. That's their whole group that they hired. They found the mean. To find the standard to find the deviations, we just take each number. So we had 41 as our first number. 41 minus the mean gave us a negative 0.5. You got to keep your signs. 38 minus 41.5 is negative 3.5. 39 minus 41.5 is negative 2.5. All the way down this list, they just subtracted the x minus the mean. This is your x's. This is all your data pieces. This is your mu or your mean. When we get down here to the bottom, they added all these up. What should happen when you add all those up? You should get 0. Because everything should be, it should end up that everything, the stuff on the low end, the stuff on the high end, that's what makes it the mean, is it's right there in the middle. All right, so all of these negatives, all these positives should average out to 0. The sum of all the deviations will always be 0. So the sum of those aren't much help. So what we do is we do the sum of all the squares. Notice, I put this in red because it's not very important. I'm lying. It's very, very important. Sum of the squares. Sum of the squares is something that we use a whole bunch. So you subtract each of those on that list. You subtract each one, and then you square those answers. And it's not, that way it doesn't all add up to 0. So it ends up being a number that we can actually use. Says treat them like they're distances. They're distances. When I walk backwards, did I walk -2 steps? No, I still walk 2 steps. All right? Distances always end up being positive. So treat them like they're distances. Always going to be a positive number. Sum of the squares. What's this symbol? Summation, parentheses, x minus mu. So you're taking the data piece minus the mean, squaring that. You're doing that. If we go back to this set, and it's probably on the next slide anyway. If we go back to this set, we're going to take all these numbers, and our next part of our box out here is all these numbers squared. And then that ends up making them all positive. And then we can add them up and do something with that. That symbol, sigma, looks like that. I don't know, last year I think somebody said that was a turbo symbol or something. I don't know, is that something?
Paint everything there.
What sigma is? This symbol. When we have sigma squared, that's your population variance. Sigma squared is the population variance. To find the population variance, the sigma squared, all you do, you sum up all those things that we were just talking about, all the squares, so the sum of all the squares, and then you divide by n, which is the number of data pieces. Number of data in, this time it's a population, that's why it's the capital N. Capital N is for population, little n is for the sample. So that's variance. Variance. What we use variance for, not a whole lot of anything. The only thing that we use variance for is so that we can get to, or the main thing that we use variance for is so that we can get to what is the standard deviation. And that's what the next part's going to tell you here in a second. Standard deviation. Population standard deviation, you use this formula. What did it do? It just took the what? It just took the square root. So you find this, and you take the square root of it. And that gives you the standard deviation. So that big long formula there that Dalton's looking at going, oh my God, what I get myself into looking at these stupid math formulas. Got all these mu's and summations and sigmas and everything crazy in there. Don't make it harder than it is. You find the variance. Once you get that answer, you take the square root, and that gives your standard deviation. Make sure you write the formulas down correctly. Make sure you can read your writing, young men. Probably comes time to take the next test. You think I'm gonna make you have all these formulas and everything memorized?
No.
Probably not. Alright? I don't care if you have them memorized. It's not the way the world works today. Because you can always get online somewhere and find something to tell you the formula, right?
I think that's the smartest thing I've ever heard a teacher say. They think that like we don't have funds to Google stuff.
Now,
No, really.
do I think that maybe you should have some of it memorized? Yeah, because if you don't, if you gotta look up every single thing, then what's gonna happen?
We're told I don't have an understanding of it.
It's gonna take way too long and you're gonna get lost somewhere through the process. Population variance, population standard deviation. Population variance is sigma squared. Population standard deviation is just sigma. Variance, sigma squared. Standard deviation, sigma. To find each of these are just a list of how to do it. Number one, first thing you're going to have to do, find the mean of the population. So you're going to have to go through, find the mean. Second step, find the deviation of each entry. So you got to take x minus mu for all the entries, however many of them there are. If there's 200 of them, you got to find all 200. Next thing you're going to do is you're going to square each one of those. After you square each one, you add them all up. I don't think there's another one on this. I have to go back. So you add them all up, find the sum of all those. That's what that SS with the little x, this is the sum of the squares. Sum of the squares. That's what that SSX stands for. This is another one of those where we're going to make this a big chart. Sort of like the charts that we made before, except this time it's going to look more like this. This is going to be your x's. Then we're going to, once we find all the x's down here, we're going to add them all up. Then we're going to find x minus mu. Then we're going to do another box that has x minus mu squared. Put all those in there, however many entries we have, all the way down through here. Once we get down to the bottom here, we're going to add all those up. What has a ugly looking summation. So if we just did something real quick while we're waiting here, let's throw in some numbers. 1, 2, 3, 4, 5, 6. Those are our set of numbers. We add them all up. That's 6, 10, looks like 21. Add them all up, write that down there. We got to find the mean. So we take 21 divided by 6. Somebody help me out. What's 21 divided by 6? 3.5. So that's our mean, 3.5. Then what we're going to do in here is we're going to subtract each x minus that. 1 minus 3.5, negative 2.5. 2 minus 3.5, negative 1.5. 3 minus 3.5, negative 0.5. 4 minus 3.5 is 0.5. 5 minus that is 1.5. 6 minus that is 2.5. When we add all those up, it's going to end up being 0, so that doesn't really help us. So we don't really have to do that. Next thing we're going to do, next column here, we're going to take each one of those and square it. Negative 2.5 squared is 6.25. Negative 1.5 squared, somebody make sure I did that one right, is 2.25, I think. Make sure I did that one right too. Negative 0.5 squared is 0.25. 0.5 squared is 0.25. 2.25 again, 6.25. Did I do both those right?
Yeah.
Then we're going to add all those up. 1, 2, 3, 4, 5, 6. So that's 1.5. So we're going to have a 0.5. That's 8, 9, 10, 11, 17.5 is the sum of all those.
How did we get calm to?
You take, for this one, you find the mean. In this case, it was a population, so it was mu, and you just take this number, your x, minus whatever the mean is. So here I took 1 minus 3.5, and that gave me that. Then I did 2 minus 3.5, and it gave me that. We add them all up, we get 17.5. Our next step, divide by n to get the population variance. So we're going to take this and we're going to divide it by n. How many numbers did we have in our set?
2.
Somebody help me out. What's the 17.5 divided by 6?
2.9.
2.9. That's your variance. That's one of the numbers that you're looking for most of the time is your variance, 2.9. On the homework tonight, that's what you'll be trying to find a lot of the time is the variance. Once we find the variance, next thing we do is find the standard deviation. The way we find the standard deviation, we just take that number, take the square root. Somebody help me out with the square root of 2.9.
1.7.
That's your standard deviation. Standard deviation. What standard deviation again means is most all these numbers in this set, the average of how they deviate from the mean is about 1.7. So most normal numbers will be within 1.7 or so of the mean of the set. That's what standard deviations tell me. So variance, standard deviation. It's going to be basically the same setup for samples, and we'll do more samples than we do populations because, again, it's easier to get a sample than it is to get the whole population. Basically the same setup. There's going to be just a little bit of difference in the formulas. So that's what I did there. You got 88.5 as your SSX. That's the sum of all the squares. Once you find that sum of all the squares, you divide that by how many there were. There were 10, so 8.9. So most of the people, if you were that 37 down there and you knew how to do this stuff, you might go in and tell your boss, hey, let's even go to the next step. The standard deviation for all the people you hired was about $3,000 from the mean. I'm way down here at 37,000. Something's not right here. I think maybe you guys ought to give me a little more money. You can only do that if you're a good part of the company, right? If you're an idiot and don't do a whole lot of work, you probably don't want to go in there and do that because your boss will probably say, what? Go away, you're fired. Sample variance. This is the formula for sample variance. Formula for sigma squared was this. That was for a population. You wrote that down a minute ago. What's the difference for a sample? It's got X bar in it, and it's got a little n, and on the bottom, instead of just little n, what is it? It's -1. This is more important. So So even though Bryce might be completely bored of hearing my voice, these are the ones that he wants to have down. Right, Dalton? Do a man a favor and let's do for me. Slips in my class. Crap. Population standard deviation. I did. It went backwards. Okay. So that's sample variance. I'm going to pop up the sample standard deviation. S, I should say that before I go on. Instead of sigma, S is for samples. S squared, sample variance. All right, sample variance, S squared. Sigma squared, population variance. Lot to remember. What do you think standard deviation is going to say? Anybody, before I pop it up here, what do you think the formula is going to look like? Tell me what's the very first thing. Yeah. S. Is it going to be S squared?
No.
It's just going to be S. This is sample standard deviation, just S. Then what's going to be next? Big square root, right? Just like for the population. And then it's going to be all this stuff in there. X minus X bar squared divided by n minus 1. They have n minus 1 here instead of n, just because somebody figured out a long time ago that if you're dealing with a sample, just like you hear all these polls and stuff and they say it's a sample of people in Ohio or whatever, well, you need to sort of spread that out a little more, because when you do a sample, do you get everybody? No. So it gives you maybe a little better idea. So sample standard deviation, just take the square root of your variance. Take the square root of your variance. Again, if I grab a calculator, we came up with this. If I grab this calculator and I hit stat, edit, I'm going to go to list 2 this time so I don't erase list 1. If I put all these numbers in the list, 1, enter, 2, enter, 3, enter, 4, enter, 5, enter, 6, enter. Be nice if all of them were that way. And I put it in list 2. And I go to stat again, go over to calculate. We want the one variable stats. This time I use list 2, so I hit second, list 2, hit enter. I look down through here, it's got the X bar, 3.5, that's what we said it was. It's got SX. Guess what S stands for? Sample standard deviation. We said for it being a population, we said 1.7. The sample standard deviation is 1.87. But then I look one line down lower, if it was a population, then it's got sigma. So that's the standard deviation. And then what's it say? 1.7. That's what we came up with. The one bad thing about this is it does not tell you your variance. And they want variance a lot. If I know that the standard deviation is 1.7, how can I go backwards and get to the variance? Square it. So you just have to take your calculator and go 1.7 squared, and it tells you 2.89. We got 2.9. All right, so it doesn't tell you variance. You just have to take the standard deviation and square it to get to that. Most of the time, you'll have to know if you're dealing with a sample or a population. Most of the time, we'll be dealing with a sample, so you'll want the S, not the sigma. To find variance standard deviation, same setup. I'm going to run through this sort of real quick. First, you find the mean. Then you find all the deviations, just like we did right here. What do you do once you find all those deviations? What do you do with each one of those? Square them. Once you square all those, you add them all up. Add them all up to get the sum down here. Then you divide by how many entries there were in the set. Actually, this time you're not dividing by how many entries. This time you're going to divide by n minus 1 for a sample. So instead of 6 this time, if this was a sample, we would do 6 minus 1, which is 5, and we divide by that. That's going to give us our sample variance. What's the last step? How do you find the standard deviation? If you got s squared here, what do you do to get to the standard deviation? Take the square root. Take the square root of that answer. It's going to tell you the standard deviation. So same steps as with population. The only thing that's different, n minus 1 on bottom, and the x bar instead of mu. So we got all those starting salaries. It says find the sample standard deviation of the starting salaries. Let's see if we can do this. We'll do it out longhand here. Help me out with your calculators. We could just plug all those into a list. We'll do it longhand and see if we come out with the same thing if we put them all in a list. So I got, we're going to have our x's. Let's put them in order. What was it? 37 was the lowest. 341s.
Yeah. 32. 45. And 46.
Should be 10 of them, right? 3, 6, 9, 10. Horrible. So we got all that. First thing we probably ought to do with all that is we need to add them all up. Does anybody remember? 415? Is that what it was? We added them up on one of the other screens a few minutes ago. So we add them all up. Take that, divide by, so you take 415 divided by 10, and it comes out to be 41.5. That's our mu. We found that on one of the other screens also. That's our mean of all these numbers. Then we're going to take x minus mu for each one. 37 minus that is negative 4.5. 38 minus that. Once you do one of them, the rest of them are sort of easy. This one's one more than that, so negative 3.5, negative 2.5, negative 0.5, negative 0.5, negative 0.5, 0.5. 44 minus that is 2.5. 45 minus that is 3.5. 47 minus that is 5.5. Then our next one is our sum of the squares. That's the SSX. That's where you take x minus mu and you square each one. This I can't do it in my head. Somebody help me out. What's negative 4.5 squared? What is it?
20.12. Or what do you, wait, 45.
.125?
Point two.
0.25. 20.25. What's 3.5 squared?
12.25.
Just squaring each of these numbers, you're squaring them. Remember, once you square them, they should all be positives. That was 12.25. What's 5.5 squared? When we get all those, we want to add them all up. Let's see if I can add this up in my head. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So that's 2.5. That's 32, 44, 50, 56, 68, 88, 88.5. Once we have that, it was a population. So we're going to take this, 88.5, and we're going to divide by n, which n is just our numbers here. 10 of them. What's 8.85. If for some reason they had said it was a sample, let's do this. That's sigma squared. If they had said it was a sample and not a population, so it was only part of the group, not the whole group, then we would take 88.5 divided by 10 minus 1, which is 9. What's 88.5 divided by 9?
9.8.
This is our variance if it's a population. This was the variance if it's a sample. Once we have all that, how do we find your standard deviation, your sigma? What do you do with this number? Just take the square root of it. What's the square root of 8.85? For this, same thing, you just take the square root. What's the square root of 9.83?
3.1.
So standard deviation, if it's a population, 2.97. Standard deviation, if it's a sample, 3.1. That's doing it out longhand. When there's only 10 numbers in the list, is it easier to do it out longhand or stick it into the calculator? Probably put it in the calculator. See if we did everything right here. 88.5, is that what we came up with? 9.8 was the sample variance. They used it as a sample this time. So 9.8 square root 3.1. It's our sample standard deviation. So if we're doing that, again, you're that guy going in there and complaining. You're saying the standard deviation, the normal deviation from the mean is about $3,100. $10,000 less than that or something. It wouldn't be 10,000 because the list wasn't that big, but. You might want to write this down. This is how you punch it into your calculator. When you get to number 9 here, is it always going to be L1? No, it just depends on which list you put all your numbers in. Put them in the first list, then use L1. Put them in the second list, L2, so on and so on. You gotta hit second, 1, or second 2, or second 3, depending on which list you put them in. What I do when I'm doing this stuff, if I put them all in a list so that when I come in here the next time and you ask me for questions on the homework, I use all the lists, L1, L2. And I remember that L1 was problem number 17, L2 was problem number 20, so that I don't have to punch them all back into the list again a second time. Try to save a little time. So you did some of this stuff last year, Mr. A's putting them in the list and everything? You guys probably did 2 lists, 2 variables of it.
Yeah.
So at list 1, list 2, and you were finding out the variation, how far this point is from the line of fit, how far this point is from the line of fit. And you'll notice I always say line of fit because when we get to that, I don't want to say the only way, because I had to do it when I was in school. But to find the line of best fit, you really need some kind of computer calculator. Otherwise, it's just so much work, it's not even worth trying to find. Unless it's a real small set of data. We looked at this on the calculator. TI 8384, what's X bar stand for again? That's your mean. That's your sample mean. Summation of X, that tells you all the X's added up. Summation of X squared, we'll talk about that later on in the year. SX tells you what? Sample, standard deviation, and then sigma X tells you population standard deviation. Notice again, no variance. Doesn't give you the variance on here. So when the question, if you use your calculator and the question asks you for the variance, you're going to have to take that sample standard deviation or that population standard deviation and square it. It's like going backwards. Key points with standard deviation. Some key ideas about standard deviation. S, the standard deviation, always has to be greater than or equal to 0. When would S equal 0? When would the standard deviation equal exactly 0? What would your set of numbers look like? It'd all be the same. Because how far does this 5 deviate from the mean? 0. How far does this 5? 0. All of them would deviate nothing from the mean. Standard deviation is a measure of variation of all the values from the mean. Not sure why that T there is blue. The larger S is, the more the data varies. So sometimes you might have something, and maybe you have a graph, and your graph looks like this. And most of the stuff falls in here. Other times you might have a graph and it looks like this. Things vary a little more on this one than they do on that. Most everything is clumped up here in the middle. So the lower the standard deviation, the more clumped up everything is. The higher the standard deviation, the more spread out it is. The units of the standard deviation are the same as the units of the original data. Variance will have units squared. Value of the standard deviation S can increase dramatically with the inclusion of one or more outliers. So your standard deviation could be really affected greatly if you have outliers anywhere. This is the main thing here. Standard deviation always has to be greater than or equal to 0. You don't talk about distances with negatives. Interpreting standard deviation, measure how much the entries deviate. We just went over this. I'm not sure why I got 2 slides there the same. So here, what's your standard deviation going to be? 0, because it's all the same. Here, notice the standard deviation is 1.2. Here, the standard deviation is higher because things are more spread out. These are the symbols that we covered when we had this symbols test coming up here pretty soon. Those are some of the symbols you're going to need to know, different things. Population and sample, know the 2 differences. If I put this on there, and you put, hey, that's the variance, I'm probably going to do this. Yeah, you're right, but that's not the answer I wanted. What answer would I want for that sigma squared? Population variance. Got to be able to tell if it's population or a sample. This is back. Must have made this slide before I knew how to use my computer a little better because my bars aren't staying with the X very well. When we do take a symbols test or quiz, you will not be allowed to use your binders. That'd be sort of worthless.
I took a picture of this. I'm not sure if I have them all down. I don't feel like bringing them all. Yes, I
I think I won't let her use her binder, but I'll let her use her phone on her test. Because I'm a moron. Sigma squared again, variance. S squared, sample variance. Sigma squared, population variance. Mu is population mean. X bar is sample mean. This here, you might write out beside this, I didn't put it on here. Symbol for sum of the squares is SS with the little subscript X. So in case I ever throw that on there, you know what that is. Every now and then when I want to make sure nobody gets 100, I'll throw something like that on there.
Here's my
That's your assignment on problem 27. Problem 27, it must have something to do with male and female. Separate them. So you do male and female separately. It'll probably make sense when you get to problem 27. Thought you were going to have no homework.
Yeah.
So I just feel
Yes, stop by. I should be here. I can't say for sure because I'm not sure what's going on.